Thank you. Thanks for coming to this presentation. So I'm going to share today some of our learning about Mongolian herders' traditional ecological knowledge, and also our initial attempts to integrate this knowledge with our field-based ecological study. Before sharing our study findings, I want to give you a very brief introduction about what is traditional ecological knowledge, and also I want to give you a brief information about what is our current rangeland situation in Mongolia. TEC is a knowledge system. It's a geographically and socially defined community that's held by this community. And this knowledge is actually related with their day-to-day interactions and relationship with the environment. And TEC is also evolving knowledge. It's accumulated, practiced, and transmitted generation to generation. In addition to knowledge of this biophysical dynamics and management practices and skills, this knowledge also incorporates place-based cultural values, beliefs, and customs. TEC studies have been growing recently with the purpose of integrating this knowledge with the scientific knowledge and to address the land and resource degradation. Because local people live on the land and they observe these changes in biophysical phenomena day to day, month to month, and year to year. So that's why they can play a crucial role in longer time studies or continuity of the studies that scientific studies often lack. Local people also hold the site-specific knowledge. So that's why they can provide useful information for interpretation about the landscape heterogeneity for scientific studies. And also, context-specific knowledge of TEC helps scientific studies and focus on more observable biophysical phenomena. And also, local people can play a crucial role in the development of sensitive and meaningful indicators to assess the rangeland condition and also a response back to management practices. So our study was conducted in Mongolia. So Mongolia has had a nomadic pastoral production system for at least thousands of years, rooted in traditional ecological knowledge. So that's what, therefore, herders in Mongolia hold vast and rich knowledge about rangeland condition and also have a very long history of knowledge. So, but on the other hand, there is a growing concern about declining rangeland condition in Mongolia due to both high stocking and climate change. In last couple of decades, we know livestock population have grown to historic highs, and in most areas, livestock have removed much of the production each year. So in the first map on the left top, you can see these areas with red color indicated that livestock have removed much of the production as of 2014. And also at some time, herd composition has changed and goat number almost tripled in response to global Kashmir demand. The diagram below this map is a summary of our study results of Mongolian Rangeland Resilience Project. And this study was conducted in 143 winter pastures of 26 SUMs in 10 AMACs, and the study was conducted between 2011 and 2012. So we call this summary as a stepwise degradation framework, and the main purpose of us to make this degradation framework was we wanted to put our plots where our study plots belong to these degradation stages. So you can see these boxes are degradation steps, and degradation step 0, or there is no degradation, we don't see any livestock-induced long-term changes. Livestock use is very light and mobile enough. But in step 1, we can see some changes in species composition, and livestock uses changes plant composition, and then we can see some changes in the abundance of palatable plants, and then we can see decreasing abundance of palatable plants and increasing abundance of unpalatable weedy species and also some annual species. In step 2, we can see some reversible biotic changes, and then it may go back to step 1 or may not. And also we can see some species loss and species diversity loss in this step. And pastures in step 3, we can see some declines in production and also some decreases in perennial species. When pastures fall into step 4, which is the red box in this scheme, we see a lot of the soil-related changes, and then loss of soil hydrological and function, and then loss of soil properties. And then we see these changes, reversible biotic changes can happen in step 1, and then if cross this biotic threshold, it may go back or may not. But if this pastures crosses the abiotic threshold, if there is a lot of soil changes, soil losses, then it will be really hard to go back to this at the previous stage. So our study shows that plots in mountain forest steppe, eastern steppe, and desert steppe mostly fall in step 1, slightly degraded. It can be recovered within maybe up to 3 to 5 years with good management. But most plots in the steppe region fall in step 2. So which means there is a crossing the biotic threshold, and then a lot of changes are happening. So that's why we said our concern was maybe steppe plots are concerned. We have to pay more attention. And also one of our recommendations from our study was we conducted this study in winter pastures. But there are a lot of discussion about the summer pastures, especially along the river and riparian areas. So we should do more systematic studies on these sites, and then see how this falls. And our classification also largely agreed with other studies. So you can see the map on the bottom. So this is the summary of the Rangeland, National Rangeland Health and Monitoring results, and the study concluded that 65% of the study sites altered from its reference condition. So you can see these orange and light blue and red dots are already altered from its reference condition. Most of these plots can recover back from between 1 and 5 growing seasons. But 7% of these red dots indicate 7% of these sites cross the abiotic threshold, and it may require intensive management implications. Climate is changing at the same time in Mongolia. So these are the works of my colleagues from Mongolian Rangeland Resilience Project. So in the first map, you can see the trend of summer mean maximum temperature in the last 50 years. So dark red color indicates that areas have been experiencing with the hot summers. And in this map, X means there is no significant differences, but if there is no excess, and then red color indicates very significant differences. And then if you look at these changes by each season, which you can see the diagram, bar graph next to this map, we can see that in x-axis spring, summer, fall, and winter temperatures, and y-axis is the rate of change. And blue bar represents the plots from mountain forest steppe. Green bar is a steppe region. The yellow bar represents desert steppe. So we can see that summer is getting hotter in steppe and desert steppe zone. But interestingly, winter is getting colder in mountain forest steppe and steppe region. So the star on top of the bar indicates there is a significant differences, significant changes over this last 50 years. Precipitation is also decreasing. So the map below the first map shows the trend of total summer precipitation, but mostly in central and some western part of Mongolia have been experiencing total summer precipitation decrease, and the areas X'd out means there is no significant differences. So my colleagues use this graded time series data for this analysis. And then if you look at this again by total amount and also days between the rainfall, you can see the bar next to the map. So we can see that amount of rainfall is decreasing in the steppe and desert steppe region. You can see this green bar with star and yellow star with bar and decreasing. But the days between rainfall are increasing. In other words, rain events become less frequent in mountain forest steppe and steppe regions. So, government of Mongolia lacks the capacity to implement, but there are still efforts to implement the rangeland assessment and monitoring. But if herders don't understand or participate in the rangeland monitoring, they will not trust or use this monitoring results. But also, community-based rangeland management groups have been established since late 90s after these 3 years of consecutive sudden droughts. And these groups have some studies show that these members of these groups are very proactive and also addressing different grazing issues, but trying to use the adaptive practice. But some members of these community groups are also included this local level monitoring. But there are still disconnect between formal government monitoring and the local people monitoring. So that's why there is a greater need to understand what herders' knowledge and how it relates to the formal monitoring indicators and measures. So with this in mind, we asked these 3 questions in this study. So first was how the herders in Mongolia assess the ecological condition of rangelands and what indicators they actually really using. And according to herders, what factors drive observed changes in rangeland condition. And then lastly, we asked, okay, what is the relationship between herders' assessment of rangeland condition and the indicators they use, and also herders' perceived drivers with our field-based ecological measurements of the same plots and measured environmental drivers. So as I was saying, we conducted our study in Mongolia and we selected 2 zones in the mountain forest steppe, Chantsallkhan and Bayangol zones, and 2 zones in the desert steppe, Undershiret and the Ritsand, and 2 zones in the desert steppe, Ulzit and Undershiret zones. And in each zone, we interviewed 8 to 9, and altogether we interviewed 26 herders across these 3 ecological zones. And then we also collected vegetation and soil data on 26 winter pastures. After we selected the zones and the winter camps, what we did was we placed our study plots across the grazing gradients from the winter camp, and at 100 meter, 500 meter, and 1,000 meters. And the plots close to the winter shelters had more impacts from the livestock. And each plot we collected the species richness, species cover, total and functional group cover, bare soil cover, standing crop biomass, and litter biomass. And after that, following year, we interviewed the traditional owner of these winter shelters, because these people have inherently, these people are very knowledgeable about the history, management history, weather, and ecology of these sites. And we brought these people to these 3 plots where we collected our data. And we did the semi-structured interviews, and our questionnaire consisted of 4 main sections. The first, we asked the general family information, and then we asked herders for us to define the rangeland health and degradation, and also we asked what indicators they use to define the rangeland degradation and the health, and what are the causes according to the observation. And after that, we asked them to rate the condition of those plots So what we did was we had a ruler and then asked them, okay, this is from 0 to 40, 0 being rangelands in poor condition, 40 means in rangelands in pristine condition. And where do you place your plots? Where do you place these study plots according to your assessment? So herders gave us this quantitative score or ratings. And we used the approach to analyze our data. We did the coding and then tried to see the general pattern, and also for quantitative analysis we use ANOVA and regression. And also we use the PCR. It's a cluster analysis in Ordination to identify distinct plant community composition and relate this to measure drivers of change in herders' rating. So this is our summary of the results. Overall, herders use same indicators in all 3 ecological zones, but there were 4 main indicators when they define the rangeland health. So this includes vegetation composition, number of plants emerge or sprout during growing season, but this was the specific term. Herders used the specific term, they called it garts. And then vegetation productivity or height, herders also used the specific term, they called it urgats. And then also herders looked at the forage suitability for livestock. But the ranking order of these indicators were different in different ecological zones. Like top ranked indicator in mountain forest steppe was vegetation composition. And then number of plants emerge or sprout, and then lastly they look at the good forage plants present. In other words, herders in mountain more looking at the amount. But the herders in the steppe region, they looked at again amount, urgats, how much production they have, and also garts, number of plants emerge or sprout, and then lastly also looked at good forage plants present. And the desert steppe, it was interesting, herders looked at more good forage plants present. So maybe this is because the vegetation in the desert steppe are more sparse. Herders more look for the good quality forage instead the amount. And of course they also, the second and third ranking was the vegetation composition and garts and plant growth. The main causes of rangeland health, according to herders of mountain forest steppe, it was livestock number. If we keep the carrying capacity low, then we will have a good rangeland, and we should have a good management, rest and rotate our rangeland, and then we also should have a good regular rainfall. But then herders in steppe and desert steppe said most important thing for healthy rangeland is a good rainfall. And also it was interesting, desert steppe herders was mentioning about summer and late fall precipitation is very important for the healthy rangeland, for rangeland health. Herders also use multiple indicators to assess the rangeland degradation, same like assessing the rangeland health. And also ranking orders were different. Like if mountain forest steppe herders mostly looking at the above ground structure like garts and the tiller of the individual plant and types of plants. If there are few types of plants and plant density are low, then it indicates the degradation. But interestingly, herders in desert steppe are looking at more below ground structure. They said if plant roots are exposed, this is the really bad situation for rangeland, it's really degrading. But the steppe herders, which is in between this mesic mountain forest steppe and dry desert steppe, they were looking at more surface. Like if there is more bare ground, if soil is getting harder, then the rangeland is degrading. And both steppe and the mountain forest steppe herders attributed the increased livestock number for rangeland degradation. But the desert steppe herders from the arid desert steppe said temporal and spatial distribution of rainfall is important and causes a rangeland degradation, and also total amount of rainfall is very important and it causes the degradation. And then lastly, they talk about the increased spring dust storm, and these findings actually support some of earlier studies conducted in desert steppe. So most of the studies, TEK studies, looking at did the more qualitative approach, but for this study we also wanted to have more quantitative indicators, and how is there any way that herders can assess rangeland condition quantitatively so that it can be easy and useful for the monitoring and management implications. So that's why we asked herders to rate the plant condition. So this is the summary of the rate condition. So, excuse me. So herders in all 3 ecological zones give the lower score to the plots close to the winter shelter at 100 meter, but there was no differences in the rating between 500 meter and 1,000 meter plots across all 3 ecological zones. So based on the herders identified indicators in each zone, we selected the corresponding vegetation in soil variables collected during our field sampling that most closely approximated herder indicators, and regressed these vegetation indicators against the herders rating corresponded with our field measurement of the same indicators. And also we selected the 5 ecological variables that were closest to the indicators that herders described. So total foliar cover, we selected total foliar cover as comparable with herders identified indicator garts, and total green biomass as comparable with herders identified indicator urgats, and cover of palatable plants as comparable with herders identified indicator good forage plants present, and species regions as comparable with herders identified indicator vegetation composition, and also litter cover. I didn't include in this first box. So what regression analysis showed us that in all 3 ecological zones, herders assessment score positively and significantly correlated with total foliar cover. So you can see in the first graph is herders assessment score in mountain forest steppe, and the middle one is steppe zone, and the last graph is in desert steppe. And besides that, also herders assessment score in the steppe zone positively and also significantly correlated with total green biomass and cover of palatable plants. And in desert steppe, herders assessment score also positively and significantly correlated with total green biomass, species richness, litter cover, and cover of palatable plants. So, sorry, maybe looks very sciencey and interesting, confusing, but what we did was we wanted to relate the causes of rangeland health and degradation described by herders we interviewed to plant community responses to grazing and other environmental variables determined by ordination analysis. So what ordination analysis do is just arranging items by scale or axis, and then graphically summarizing this complex relationship. So I'm trying to simplify this and make simple words for this. And so there are complex relationship and show the patterns. So in this case, in community ecology also, this ordination analysis is used a lot. So what does it do is describe the strongest pattern in species composition. So, and also species composition varies along the environmental and historical gradients. So in this ordination, this is the results from mountain forest steppe zone. So what we see is there were 72 species recorded during our field work, and then these 72 species are split into 3 main community groups. And then you can see this, sorry, this one is not working. The species in the red polygon is the community group 1, and species in around this green polygon, green line is community group 2, and then light blue is the community group 3. So this community group display a typical pattern of how vegetation responds to increased grazing pressure. So community group 1 in this case is more grazing tolerant, increases from moderate to heavy grazing, and usually with the ruderal strategies. And then community group 2 are more palatable and characteristic species of mountain forest steppe, and they usually decrease when grazing pressure increases. But the community group 3 usually also increase for a certain level with increased grazing and then decreases. So you can see this kind of hump shape, right? So, and So environmental drivers we included in this study was, so these community groups are displayed in this ordination space, and then we looked at, okay, what environmental factors are driving these changes? And we included some environmental variables, aspect you can see there, and then also growing season precipitation. So it's marked MGGA, but it's overlapped here, so you can see in the next graph, next slide. And then also elevation, slope, and we also included this long-term yearly mean average of rainfall from 1979 to 2012. So it's marked like CPC underscore dash and mean. And also besides these environmental drivers, we also included the total livestock number of these families in this zone. So it's marked total slash SF. So this is the livestock number by sheep forage unit. And then also we included the distance from the winter shelter, and also we included the herders' ratings in this analysis. So you can see H score. This is the herders' rating. So in the mountain forest steppe, main axis is correlated with the total livestock number. In other words, axis 1 is correlated with the axis 1. And also long-term precipitation and growing season precipitation correlated with the axis 2. So what does it mean is plant community composition is changing. Main drivers of the plant community composition change is this livestock use and also precipitation in this zone. And also we can see that herder score, H score, I did put the circle, shows that herders tend to give lower score to the plots with community group 1. The dominant species are more grazing tolerant and increaser species. When herders look at this species, they tend to give the lower score. That's why the vector is the opposite direction from the total livestock number. So if you have questions, please ask. I'm afraid if I'm not explaining clearly. Okay, so that's the results. So if we remember what herders told us when we were interviewing, they said top ranked indicator of the rangeland health and degradation was plant composition, right? So these also supported by this. And then also we were asked what causes the rangeland health and degradation. They said livestock, stocking rate, which is also supported by this ordination analysis. In the steppe, 52 species included in the classification, and we found 5 community groups. So grass species in community group 2 and 4 are more palatable, also characteristic species in the steppe. You can see these species around the green polygon and species around the pink polygon. But the dominant species in community group 1, which is around the red polygon, and community group 3, blue polygon, and community group 5 are more grazing tolerant and increaser species. So in this zone, it's very interesting, like plant community composition are identified by the palatability and characteristic species. And then when we run the ordination, we see that MGGA's growing season precipitation is correlated with the axis 2, and livestock number, total livestock number, sheep forage unit, and slope were correlated with the axis 1. So in other words, in this zone, precipitation, livestock number, and slope are main drivers of the plant community changes. And also, interesting thing was, herder score were also correlated with the axis 1. But it's, of course, herder score is not a driver of change, but we just included in this analysis how it relates with our other environmental variables. But interesting thing was, herders tend to give higher score to those plots with the palatable species like steppe or the Steppe krelovi and the steppe gobica plots, but the direction of the vector was same with the total livestock number. So this was a little bit confusing, but what we say is herders tend to give higher score to these plots with good vegetation, but also they place more livestock on those plots. In the desert steppe, 37 species were identified, included in this class, and then there were 4 community groups. The classification was more about also relatively stable and rapidly recovered plant communities. So long-term precipitation, which is CPC mean, and then growing season precipitation correlated with the axis 1, and aspect and slope correlated with the axis 2. So what it means is, in this zone, precipitation is the main driver of the vegetation changes. So if we remember what herders told us in this zone is, main indicator of the rangeland health was the forage suitability for livestock. And also main causes of the rangeland health and degradation is the precipitation, so which is also supported by this analysis. So in conclusion, we see that herder interviews revealed that indicators herders use to assess rangeland condition correspond with indicators typically used by rangeland researchers, us, and for foremost rangeland monitoring. So herders' quantitative assessment also correlated significantly with several measured ecological indicators. So in most zones, their assessment also correlated with measured differences in plant community composition. And lastly, herders' ideas about causality of rangeland health and degradation were supported by our ordination results. How we can use these results for the management implications? We see that herders use the specific terms in their assessment, like urgats and garts, but these terms are not really used in our current rangeland monitoring. So if herders don't understand the current rangeland monitoring terms and they are not really involving in this, then it will, as I was mentioning before, they will not use or maybe will not trust. And I'm kind of trying to, okay, what is our current rangeland management practices and how we can include or provide our study results to improve these management and monitoring practices. So at the moment, Institute of Meteorology and Hydrology conduct the rangeland monitoring. So they also used the indicators what we used for our ecological study. I put all the information here, but monitoring plots are one plot in each bag, which is the smallest administrative unit. And then some meteorological station worker usually conduct this once a year, usually in August. And then they report this information to Mofali, Ministry of Food and Agriculture, and then NEMA, and send to those AMEX they requested to have information. And the main information in this monitoring is identified rangeland condition, carrying capacity, stocking rate information, and send it to all AMEG and SOM, and also they place in their website, so everybody can access that. Another monitoring is conducted by land agency, Alagak, and this is also use similar indicators, but they approach, the method is a little bit simpler. They are using also photo monitoring. Volga maybe you can also add if I leave some. And usually some land manager conducts this monitoring, and they produce pasture carrying capacity in rangeland recovery classes, and by each SOM and bag, and also maybe by each community groups, pasture user groups, and they use this information to develop the SOM annual land management planning. And also, land manager inform the information to the SOM level pasture user group or herder groups. I don't know much about that if the herders are really involving in this monitoring, but they get information about the rangeland monitoring. So what we are saying that like our study shows some promise for developing these integrated indicators that incorporate important herder observed indicators like urgats, garts, and also palatable plants and soil-related informations. So if herders understand these indicators and what they use, and if these indicators are integrated into the formal monitoring, this will be very useful for herders and for the management implications. And even if herders don't participate in the monitoring, they still have a more informed about what's going on about the rangeland conditions. And of course, the participatory monitoring is rangeland monitoring is very essential. And I think this is the very first step to involve herders in the rangeland monitoring is having the same terms and same understandings. And then if this helps increase the trust and use of monitoring results for herders, you can see the below arrow, down arrow. And also, this helps these community groups do the rangeland monitoring more organized manner. So that also helps to improve management, and in the long run, it will help more sustainable stewardship. And for the government level, if herders involved in the rangeland monitoring, then it helps to improve the temporal and spatial scope of the monitoring and better coordination, because given the nature of using the shared resources, so this is very important to be informed to the policy level, and so that improve management and also helps to develop the appropriate policy. Also, given this large number of CBRM or community-based groups in Mongolia, organized in Mongolia, we also propose that herders can be invited to the formal monitoring, and then they can contribute the informal observation in a more systematic way, so that broad-scale monitoring efforts can be established. And also, we can train herders so that they can help to collect the data using this set of indicators, like common indicators. But maybe this can be expensive or time-consuming, and also it requires the herder's willingness. So what is the other option can be easiest and also useful if you want to include the herders in monitoring. So we think that maybe if you use the cell phone, and then because every herder in Mongolia have a cell phone, not necessarily a smartphone, but they have a cell phone, so then we can develop the simple interface so that herders can record quantitative assessment, like given the summer pasture, they can give the score, and then also they can document the observations, why they give this score, and then send it to this, the central the places. And then so it will be easy to collect the data at some time, and also more broad involvement. We can involve herders more broadly, and also it can also help to reduce the delay of the monitoring results, because currently there are always delay between the data collection and then data analysis and then reporting back for the management implications. So if you use this easy tool or apps, then maybe it reduces these challenges. And there are some initiatives in US, like land PTAs. So they are also testing like these approaches. So for our case in Mongolia, maybe we can use similar app and then develop this interface. And the other thing is maybe we should translate this information so that herders can use it easily. So with that, I can take questions, and yeah, that's.